when you're solving, and again, it says to solve and check, but remember, I'm only going to make you check if it is a logarithm and if there's what? Yeah, two solutions, okay? And then, so for number one, you can't rewrite those as the same base. And you can choose how you want to use the log, because you can either use the log of base 10, or you can also use what? Yeah, do you guys use the log base 10, or do you use log of 5?
Log of 5.
Okay. Okay, so if you do log base 5 on both sides, that seems to be the popular consensus here. Okay, what would happen is these two would cancel. You'd get 2x equals. Now, when you have log base 5 of 20, this is the change of base formula. So you have the log of 20 divided by the log of 5. You have to know how to use the change of base formula. Okay? So it's the log of log base b of x, right, equals the log of x divided by the log of b. And how do you remember which one goes where? Yeah, the first one goes on top, and then what's the second one? How do you remember the second one? Yeah, the base goes on the bottom. Okay? Now what I would do in my calculator is I would calculate that and then do the second part. I don't know if that's helping or not helping. Like the 70s things we have going on there, but
How are we supposed to do it without
you can't. I just said, I know, I roll out for you 1 and 2. You have to use your calculator.
I thought you were talking about the 1 and 2 on top. Well, there's 2, 1 and 2.
Okay, but there's no way that you can rewrite 20 with a base of 5, right? This would have to be 25. Yeah, there's no way you could solve it correctly without it. So when I do this, I would do the log of 20 divided by the log of 5. Okay, and then your final step is going to be to divide by 2. So divide everything by 2, and then I would do it like this. Oops, not that. Okay, so divide by 2, and then if you're rounding to 4 places, it would be 9307 if you rounded. If you do these two at the same time, you'd have to do the log of 20 divided by, and then put in the parentheses 2 log of 5, so that's the only reason I would recommend doing it in the 2 steps. Okay? And then number 2 is the same process, except you have to add 8 and then divide by 2. Okay, what's another one?
3.
Okay, so 1 and 2 you could use a calculator. When you can't use a calculator, you always want to rewrite with the same base. So what base can I use? Yeah, let's use 2. So this one already is written in terms of 2. This would be 2 squared. Once you have the same base, then you set the exponents equal. So rewrite with the same base, then you set the exponents equal. Okay, so then you just subtract 6 from both sides. X equals -4. There you go. Okay, what about 4, 5, 6? Okay, so for 6, you can see this is going to be 5, right? So 5 squared to the x, this is going to be 5 cubed. Now the thing you have to remember is when you do a power to a power, you multiply. If you have more than one term, you have to distribute. So this has to be 3x minus 6, not minus 2. Okay, did you guys remember to distribute? Okay, so then you have negative x equals -6, which means positive x would equal positive 6. Okay? with this one, if you were thinking, oh yeah, 81 is 9 squared, and you wanted to find 9 cubed, then you'd have to do 81 times 9 to find out what 9 cubed is, and it ends in a 9, so you know that there's no way that can work. But another way you can rewrite 81 is 3 to the 4th, and then 243 would be 3 to the 5th. Okay, and then again, you have to make sure you multiply these. So this is 1x equals 4x plus 20. And then you would move all of your x's to one side. And then this one, you would just leave it as a fraction. So you would just leave it as negative 20 over 3. Okay, you don't have to do any other calculation. Yep.
If you do have, say, bases where you can do the rewriting, if you didn't rewrite them, could you still use the log function?
Wait, say it again. Say what?
So if those do have the same bases, but
Yeah.
would it be possible we can still get the same answer if you did?
Oh, if you did, yeah, because if you did log base 2 of both sides, what happens? If you have log base 2 of 2 squared and log base 2 of this, don't those cancel out? So then you just end up with this. So you just be writing like an extra step out, so you don't need to. But yeah, mathematically it is sound. Yes. Okay, what about on this page? So first let's look at the top, the 7, 8, 9, where you have some of those fractions. How did that go? That went well? Okay. So, yeah, okay, can we do one? That, maybe, let's even do like 7, because how are you doing with something where you have to rewrite 16? What would it be?
I'm doing like 2 to the 4th.
Yeah, 2 to the 4th. So don't evaluate it, because the main thing is rewrite it as the same base. You could do 16 squared, you could do that, but if you're looking at this, it's the 1/2. We know that's 2 to the negative 1, so then it might be simpler if you're doing this without a calculator to think of it as 2 to the 4th. Okay, because 2 to the 4th is 16, right? Okay, so then you would just have negative x equals 8. So 8 equals negative x. And it would just be a lot less stressful mentally. But you could still, again, you could still get there. If you change this into 256, then you would just write out 2 to the 6th, or 2 to the 8th power. It would just take you a little bit longer to get there. But it would still be fine. Okay? And then one like this, like if you notice that you're getting these wrong where there are 2 terms in the exponent, it's probably because you forgot to distribute. So this would be negative 3x plus 18 equals 3. Because once your bases are equal, you're going to set your exponents equal. Okay? And if you're like feeling uneasy about those, just subtract it first and then put your sign. 18 minus 3 is 15. Negative divided by a negative. Or you can switch it to make it positive, and then you can always plug it back in and make sure that you got the right one. Yeah, Andy? Oh, no. In fact, that's actually what I did on this one. So, yeah, for that one I actually did use 27. Because then you don't have to change that at all. Yeah.
Oh, wow.
Yeah, absolutely. Okay, for this one I changed them both to base 2. Just be careful because sometimes people think, oh, 4 times 8 is 32, so I can just rewrite this as 4 to the 8th. No. Really, your base is going to be 2, 3, 5. Like it's, most of the time you can write it as those single digits. Yeah? Yes, I will. Let's look at this row. This one you're solving. These are the ones where you have to put the power in front and then you divide each side. And then don't forget that you can rewrite using the exponential function. Okay? Anytime you get to a single log, you rewrite it with an exponent. And don't worry about like furiously writing this down. I'm gonna post this, so I'd rather just, let's focus on some that we need help with, but you can see this whole row practices that skill where you're dividing, okay? You divide by 3, you divide by 6, you divide by 5, okay? So that can help you. This whole row is the properties when you have minus or plus in between. Well, actually those two are. And then if you have the log of x over 10 equals 14, you can exponentiate or you can rewrite it as an exponent. So like 10 to the 14th. Oh yeah, this one was kind of strange. Sorry about that. And then you're going to multiply both sides by 10. So there won't be one that's like this, but remember, if you multiply a base by the same base, what do you do with the exponents? Add them together. That's where that comes from. So if you haven't been dealing with significant figures, that was probably too tough for you. No, not like where you have to, not like that without your calculator. Mm-hmm.
For 13, is it okay if we wrote it as 1 times 10?
Yes. Yep. And I put that on the answer sheet. Or if you want to write it out, you could write it out there as well. 5x. Yep. So this one you have exponential. Okay. Now please notice on ones like 15, where if you have the same log on both sides, you just set what the logs are of equal to each other. If it's the same log, you set those equal and you solve. Okay. Yeah, so
So if that's the same log and then the exponents, can you do the same thing with the exponents?
you're gonna have to do that out. So that's what we'll do for 18. And then let's look at 16. So for 16, you're doing division, and then remember, whenever you have a fraction, to undo the fraction, multiply by the denominator. So this is just x plus 4 equals 60. Subtract 4 from both sides. Okay, for this one, because it's the plus, you're going to multiply. And then from here to here is just rewriting as an exponential function. Okay, divide by 25. And then make sure that you do have the plus or minus. Now, because you have 2 answers, we're going to check them. Question about one of these steps?
So for 16, I don't know. Is that like a multiplication between the 2?
Once you have the single log here, it's the base of 10, right?
Right.
So 10 to the first equals this is what I have, and then I also did the multiplication, both sides by 6.
Okay, because that looks like a minus symbol to me. I don't know. Maybe
Yeah.
I'm just blind. I don't know.
Nope, you're fine.
It's just like,
Yeah.
it's confusing.
Can you bring the log over to the other side
For which one?
for 60? That's the easiest part.
Okay, so maybe that's one that we need to do out from start to finish as well.
I got 999,000.
Yikes. Okay, so the thing that we should notice here is this is minus. So if it's minus, we're going to rewrite this as division. So how did we do about the first step? Okay, and then what about writing it in exponential form? Okay, so exponential form, remember, it's just your base, your answer, your exponent. So your base is 10, your exponent is 1, and then this is what your answer will be. So 10 to the first is just 10, right? Okay, so then we're going to multiply both sides by 6. So 10 to the first is 10. 10 times 6 is 60. And then we'll just subtract 4 from both sides. Oh, okay. It is a little bit tricky, like remembering that. So always think about, can you rewrite it in exponential form? And then, how was 17? Is 17 okay?
No.
Okay, is the first step okay? 25x squared?
Yeah.
Okay. Second step is, again, just the base, answer, exponent. 10 squared equals 25x squared.
Yeah, I just didn't know that you went like straight to writing it.
Yeah, yep. Anytime you have just a single log means you're going to rewrite it in exponential form. So we're using that definition over and over and over again. So we're dividing by 25 to get 4. And then because we have the plus or minus here, we're going to have to check them both. Okay? So when you're checking them, you have to make sure that you're writing out the check for both of them, okay, whether or not you think they're both going to work. I wrote mine on another sheet of paper. So when you plug in the 2 into the original function, which is where you have to plug it in, it's 2 squared plus a log of 25 equals 2, and then 2 squared is going to be 4, and then you can use your product property to rewrite this. And then, yeah, the log of 100 is 2, because 10 squared equals 100. So, yes, that checks. Now, the negative, which a lot of times we've seen that the negative doesn't work out. But look, this is one of those cases. If you have negative 2 squared, you simplify that to a positive. So, yeah, so that's why you want to check it. The same thing happened with 18. So when you were doing this one, if you notice that the logs are the same, don't even worry about moving that exponent over. It's going to be a lot simpler if you set these equal to each other and solve. Just remember, if you have x minus 1 squared, it's x minus 1 times x minus 1. And that is x squared minus 2x plus 1. And then anytime you have x squared and an x and a number, start thinking of factoring. Start thinking of quadratics. Okay, because you are gonna have to know how to handle a quadratic here. Okay, so you're gonna factor. So what multiplies to 2 but adds to 3? 2 and 1. So then x equals negative 2 or x equals negative 1. So our first instinct might be to, yeah, hopefully it is, right? To throw out those answers because they're negative. But this is another special case where when you plug it back in, you're squaring it here. And on this side, a negative times a negative is becoming a positive. So both of those ended up working out. Okay, and you do have to make sure that you show those. You have to show both of them, and then this would be your final answer. And then if it didn't work out, you would only put one of those answers, and that's what happened on your bell work today. So I'll show you that one. Oh yeah, yes. And again, you only have to check when there's what? You only have to check when there's 2 answers. So on your 4.5, which one had 2 answers?
Wait, for the warm-up?
Yeah, for the warm-up.
Wasn't number 4?
Nope.
No.
What?
Number 3.
Number 3 was this. I didn't do that.
Oh, wait.
I did